Hi guys, the intent of this video is just to give you a little help on the Are You Ready packet. Usually what I do at the end of each school year is I go visit the pre-calculus classes individually, and I just, do a little Q&A. Sometimes I even bring like a current student in. Obviously I couldn't do that at the end of this year because of our distance learning, so I'm going to be doing it at the beginning of this year. One thing we're going to do is before you start, I'd like you to take one period of time. I think this whole packet would take maybe hour and a half, and do this before class starts. Now obviously I can't give homework before school starts, but I am going to give extra credit if by the start of the first day of class, yours is already complete. And to do that successfully, I wanted to provide you with a little bit of video help. So that's what this is. We'll have a lot more intro stuff once school starts as far as what you can expect with the course, what programs you need, what codes. I don't even know if we're doing full distance or hybrid right now because I'm making this video before that's even been known to me. So, we'll get all that stuff taken care of once school starts. But this is just, are you ready? Do you know the basics that we need from Algebra 2 primarily and then from pre-calculus to get started? So if you need more assistance than what I give you on this little video, just go to Google, go to YouTube. If it's horizontal asymptotes, just Google horizontal asymptotes and find something that clicks with your brain. All right, so we're just going to dig right in here. If you don't need any help on a particular section, just fast forward on through and go from there. So I'm going to go do a little screen share here off my iPad, and let's begin. So first thing here we have is evaluating a function. When I think of f of or h of x, I always think of the y value at that x value. I think of what goes in, or what we sometimes call the independent variable, or the x, and what comes out, or the dependent variable. Now in calculus, we aren't going to be using, because it's real life math, usually our independent variable is time. And our dependent variable is something that changes over time. So we might have a W of T, where W is the water level in a water tower or something, or P of T, where P is the pressure in a valve. So our functions are going to be more applicable, and our X values are almost always going to be time values, but just so you know that. But really, I mean, you should know how to evaluate. And when it says f of x plus h, we take that x plus h in and we put it in for the input, or the x. So each x here will be replaced with an x plus h. Make sure when you square it, you FOIL. And again, there's solutions that I'll publish to this too. So, if you get it all right, just skip on over. All right, the next thing is, remember I said to think of f of as a y value at x. So let's suppose I put a solid dot here and I asked you for f of 5. I'm asking you for the y value when x is 5, in which case for that one, it's 1. Now, if I had an open dot there, you're used to from your previous courses putting undefined, which is totally true, but we call it D and E. So if I had an open dot there, I'd say the F value of 5 or the Y value of 5 does not exist. So we'll be using D and E instead of undefined. We primarily use point slope form in here for a form of a line. So you can we don't use standard form, we don't use slope intercept, we use point slope. So you always need a point and a slope, or a point disguised as the y value at -5 is 7 and a slope. Or in this case, I have 2 points, I'll need to find the slope. And you should know how to find the slope of a line. Tangent lines are really important in this class, and you'll learn why later. But we need to be able to write the equations of tangent lines. All right, and so we need a point, and we need a slope. So for each one of these, tangent means to touch at one place. This red line is a tangent line. You need to grab that point of tangency and write it down as x comma y. And then you need the slope of that line visually as rise over run. And then we do point slope form of a line. Okay, remember how to find slope, change in y over change in x, correct? This says which one represents the slope of the secant line. Now, secant lines, unlike tangent lines, hit curves in 2 places. So you would be asked which one of these is the equation for this secant line's slope, which means you need the x values and you need the y values. Okay, so I'm going to erase this a little bit. It would be up to you to find which one represents change in y over change in x. In this case, the y values are f ofs, so we're certainly not going to be using a, that's change in x, over change in y's. I'll let you wrap that one up. Same here. Slope of secant line, we need to have change in y's over change in x's, so we obviously wouldn't use this one. It's up to you to decide which one of these three it is. Again, writing this as the point x comma f of x, and this as the point x comma f of x plus 2. Which one represents change in y over change in x? And ditto for this one. This one's really important for us. So I'm going to leave that one undone too. But again, write these as points, x comma f of x, and x comma the y value at that x value. And then we do change in y over change in x. Okay, oh, this should be an x plus h. Sorry, kiddos. All right. I'm going to move right along here. So when we talk about interval notation, all right, we don't use inequalities in here for our domains and ranges. We use interval notation. So I'm going to actually go through this first one with you. The domain is what x can be. So we're going to talk about what it can't be. I'm fine from negative infinity all the way to -1. Then I hit a vertical asymptote at x equals, it's a line, right? Asymptotes are lines that we approach, but we never quite can touch them. All right, so vertical asymptote at x equals -1, right? Then it looks like I'm good from, so I'm going to union it up with, I'm good from open at -1. Remember at -1 there was an issue in the domain. I can't quite grab a y value when x is -1 because I'm heading to the infinities on both sides. So, but I can go from -1 to 1 and open, but then hit another vertical asymptote, hit a brick wall at, I don't have much real estate at the bottom of the screen here at x, whoopsie, at x equals 1. Holy crap, I apologize. I'm clicking like crazy here. So anyway, at x equals 1, you can write that on there as well. For some reason, when I'm trying to write in the corner of the screen, it's backing me up. So, all right, then I'm good again. Where am I good from? I'm good from open at 1. And it looks like I'm heading with this arrow on out to infinity. That's my domain. That's what x can be. I'll let you decide what the range is or what y values can't touch this. And then we also then get our horizontal asymptotes at those y values that are excluded from the range. Okay, so you'll notice right here, I'm heading along, but I'm never going to get past y equals 3. There's no x value that I can plot and hit y equals 3, so that's one of my horizontal asymptotes. I'll let you work through those other ones on your own. Keep in mind, there is a key, so make sure you're checking those suckers, all right? Vertical asymptotes analytically or with algebra, the last one was graphical. For vertical asymptotes, really there's only 2 things in math you can't do. You can't divide by 0, right? Ever. And you can't write negative numbers in real life. Like we have our imaginary number system that allows us to get past that. But because calculus, again, is applied math and gets applied to real life situations, you won't see a single complex number or imaginary number. So when we talk about vertical asymptotes, and remember what they occurred on the graph, they occurred at what value of x's weren't in the domain. In other words, what x can't be helps you find your vertical asymptotes. So really, when we have these fractions, we focus on the denominator. We focus on what makes the denominator 0, noticing that we might have to factor, right? But if after factoring, we cancel with the numerator, that's another issue. So for vertical asymptotes, what we do is we look at the denominator, look at denom. We might have to factor. In this case, I have a difference of squares that needs factoring. In this case, I have a trinomial that does factor. So we look at factoring, then we cancel. Then we look at what's left. Watch. I'm going to make one up that's not this one because, again, there's not a whole lot of practice on here. It's just to bring things back. But vertical asymptotes pop up quite a bit in this course. So let's say we had, I'm just going to make a super basic one, x plus 3 over x squared. Let's do plus 8x plus 15. All right, so let's focus on that denominator. Let's factor x plus 3 times x plus 5. Let's cancel. And now let's look at what makes the denominator 0. So we have one issue in this one. Our issue is that at x equals -5. What that means graphically is we'd have that can't touch this vertical asymptote there. All right, so let's go down here. I'm not going to go over this. I think this should be fresh enough for you from Algebra 2. If not, the rational, by the way, means can be written as a fraction. So there's an example of this. It's negative because the radical was in the denominator. It's 2/3 because we do in over out. Okay. I'll let you deal with that. These two sections are just, I mean, if you need to Google how to work with rational exponents, do so. But I think just looking at the key will clear up that. Same here. I'm not going to really go through the unit circle, but man, is it important for us. Sometimes, like if I were to ask previous students from previous years, like, what's the biggest thing you need to take out of pre-calculus? They would say the unit circle. A lot of the other stuff we use in Calc 2 or pre-calculus means pre for all the calculuses, which usually go through Calc 4. But we use so much of the unit circle. So if you need to, if you've got it, great. If not, you need to be able to do it without looking at it. You can draw it out, but the AP exam is timed, so that might be time worth saving. I'd like you to just look at cosine pi fourths, think about it for a second, and then root 2 over 2 eventually. Okay, if you don't know where that's coming from, again, Google unit circle. There's games out there. Again, if you just go copy the key, that's worthless in the end. All right, so unit circle, Google it if you need to. When we solve an equation in this class, we're going to assume most of the time that you don't have a calculator. So what we do is, you're going to hear me say this a lot this year, but whenever we solve and we don't have a calculator, it will factor. It may factor weirdly, but it will factor. And then we get it equal to 0 and find the zeros. All right, so that's usually what we do when we have things like, let's say, this guy, like we will factor that, get it equal to 0. We would factor this, get it equal to 0. We would factor this. Each of these would have an e to the x in them. And then when we multiply, we add the exponents. So e to the x times e to the x is e to the x plus x, also known as e to the 2x. And then that would be -1. All right, once they're factored, I mean, again, you wouldn't factor this guy because it wouldn't factor. It doesn't have anything you can pull out of it, but then you would just say, well, e to the x would have to equal 1. Maybe you just know that that's a 0. That's the only power you can raise a base to get 1. You could just write x equals 0. Or maybe you remember your teacher saying, well, you natural log each side, which is totally fine. But then that requires you to know that the natural log of 1 is 0, right? And that you bring that exponent out front, and the natural log of e is 1, and I get that x equals 0. But I think it should have been evident from up here, and the common sense is king in this class, so I would just use common sense at this step. All right, but anyway, let's go back down to this guy over here. Notice how I factored it. I noticed that I had e to the x living in both pieces of the difference, and so I factored it out. And then I look at, can e to the x equal 0? You should know it can't. Either because you remember its graph looks like this, or you're thinking, what power can I raise e to get a 0? Well, you can't raise any base to a power and get a 0. So this isn't going to provide you with a solution. For this one, I'd need e to the x to equal 1. And again, we just talked about that up here. So this would have one solution, and that would be at x equals 0. You could go test it. We'd have e to the 0 minus e to the 0 equals 0. All right, solving equations. All right, with trig. So again, unit circle really important, and I could spend a half an hour right here talking about it, but some of you wouldn't need that. So I don't want to do that. I want you, there's so many good videos out there, but remember, you're just kind of looking for, let's go down to this guy, cosine x. I'll just get it really brief on our unit circle. The ones that we know without a calculator are at pi sixths, pi fourths, pi thirds, and then equivalently we go all the way around, right? And you should know how to create a nice unit circle. We should know that at the pi fourths, and again, notice I'm not saying 45 degrees, we don't use degrees in here, that the x and the y values are the same. So cosine and sine are the same. There's so many good proofs of that, but we'll deal with that later. I might even take a day and just cover the unit circle. I probably will because it's that important. But I'm looking for where the cosine of the angle or the x value is root 2 over 2. I can see that that happens there at x equals pi over 4. But the x's are also positive over here. So I would need to know which one this angle is. And you might say negative pi fourths. I prefer you don't. I prefer you head around this way. We have 1 pi fourths, 2 pi fourths, 3 pi fourths, 4 pi fourths, also known as pi, 5 pi fourths, 6 pi fourths, also known as 3 pi over 2, and 7 pi over 4. All right, if that was way too fast for you, again, don't worry about it. Maybe Google it and get a little somebody else explaining it, and I think I'll probably spend a class period on the unit circle. Domain and range, it helps if you know what the graphs look like. It helps a lot if you know and have memorized your parent functions from pre-calculus, that natural log looks like this. And if you're like, I didn't know that, you would by the end of the year. That's not something that you say, I'm going to drop. I didn't know what the natural log graph looks like. Well, then go to your calculator, type it in, and look at it, right? So when I'm looking for the domain, I want to figure out what can x be? Well, you'll notice, again, I have this vertical asymptote. I can't touch this coming like this. So I would start at 0 open, or we call that a wimpy and a beefy bracket. That's a wimpy bracket. And I'm heading on out to infinity. But you'll notice the ranges, although it's climbing slowly, it's eventually going to hit every y value positively and negatively. It is unbound. It has no horizontal asymptote. So we go negative infinity to negative infinity. It helps to know what the graphs look like. So if you need your calculator to revisit the graphs of some of these, that's totally fine with me. All right, I'm going to not simplify. You should be good with that. I'm not going to do these either. Remember, this means this symbol, if you're like, oh, what's that? It's not reciprocal, it means the inverse. So f inverse of 4. Remember, for inverse functions, the x's and the y's swap. So if, like, say 3 comma 7 is on f, then 7 comma 3 is on f inverse. So if you're looking for f inverse of 4, it means 4 is the x value on the inverse function, 4 comma something, which means something comma 4 was on the original. We need to go figure that out. What got mapped to 4? And it's this guy. So our points on f is 2, 4. On f inverse, 4 would get mapped to 2. So we'd say f inverse of 4 is 2. All right, did I reach the end yet? I did. Now, that was really fast, right? It wasn't intended for me to be teaching you all that stuff. I just started kind of to bring it back. You should maybe struggle with a few of the simplifying, again, use YouTube, use each other if you know anyone else in the class. I think the only thing I'm probably going to spend a day on will be that unit circle. And we'll just see out, maybe do a poll and see who thinks that would be beneficial. Remember, we're on a time crunch, so be honest. If you're like, I don't need the unit circle, don't just say you do to have an easy day. All right, so great. The key to this I will have readily available to you to check your stuff once Schoology is up and running. All right, so have a good one. A lot more to come once school starts. This is just something I normally would have passed out to you at the end of the school year in pre-calc, and I would have said, like, sit in your bedroom, and then I'd send you a message that says, you know, take out that packet and start it like the week before school. So again, in getting it done early before school starts, I'll give you extra credit on it. Otherwise, a due date will be forthcoming, like a day at which I won't accept it passed. All right, so have a good one. I hope all is going well, and I really look forward to meeting you guys. Calculus is an awesome class. All right, so let's end this meeting. See ya.